So today we are going to talk about a really complex topic, the grading of a riding boot. So this riding boot here is not a classic one. This is a fashion one I create for a customer, but the problem is pretty much the same. We have measurements here. We have to accommodate those measurements. In case of real riding boots, sportswear, they need to be very specifically very accurate. We even have to put into consideration that there will be a boot tree incorporated in the process. In this scenario, is going to be just a leg, so we have to make it somewhat good looking, comfortable, and function as a fashion riding boot. Now, let's say we got this measuring sheet from the customer and we have certain measurements what we need to incorporate here, and the size is going to be let's say 39. It's not really 39, but we can go down here and measurements going to be just fine. So let's put the measurements in here. So Caligula does something pretty genius. If I measure the uh, width in here from the axis, it's always going to be perpendicular. So I can put this measurement here to this line and I can check it. So this is 173, and I need well, a little bit more than that. So I'm gonna just change this line. But even Caligula is very smart about that change. So I can do this. Wouldn't be pretty cool if I would have something a lot easier, a lot more handy than that? And believe or not, there is an option for that. So let's build up a system first on the model size, and the system gonna go this way. So I'm going to put a parallel line in here. I should have choose the free one. So I put this line somewhere here. Okay, and let's put it 180. I'm gonna put one line in here, and I'm gonna just use this line as it's supposed to, because this is gonna determine the ankle. All right, so what we're gonna do with these lines? So something pretty brilliant. I'm going to choose the curved fillet tool and start with this line right at the intersection and just put it in somewhere here. So this is going to give me a curve, and I can shut down this part, so it's going to be just a nice curve in here. But I'm going to need another curve in here, and they're going to be dependent on this line. So every single time I need to adjust this line up and down maybe. As you can see, both line will change in the same time. Wouldn't it be a lot smarter if I would start with the other line? I should have done that at the beginning. Put it to the actual contour curve, which is determined by the lost. So it is what it is. And then I'm going to go to this line. How beautiful it is already. And then I'm going to create the next curve from the end point. So no matter what, that's going to be accurate. And I'm going to put it down to the intersection like that. And here's a trick. I can fix this to the intersection. So from now on, if I would move this line anywhere, that would change as well. How cool is that? I can do the same, putting one line here. Actually, let me copy this line. It's easier. So let's put this line here. It can be a certain ratio, or it could be a certain measurement. I always go with the ratio in these scenarios. So let's say I'm going to put this line down here. Let's put it to the ground level. And I'm going to put a midline in between, but not there, but somewhere here. Okay, so this is going to be 3367 between these two. And now only thing I have to do to bring this down to the right intersection and fix it to the intersection. How cool is this? Because now what I can do is move this line wherever I want, and the cuff proportion will be always where I need it to be. So that is pretty neat. In the same time though, so if this distance is too much, and it's way too much actually, so in 38 I only need well, this is the the C measurement, so a little bit less than that. I'm gonna put it down a little bit less than that. So these boots actually in this point can be a little bit tight. And also if there is a elastic piece incorporated, you definitely want to do it a bit more tight. So I can put it wherever I want, and as you see, the other line is beautifully following. So both lines gonna draw this nice curve right away where it's supposed to be. So let's put it in here. For the side note, this is not gonna be graded. So if you want to have it graded, you have to create an independent line because this is a fixed distance. No matter where you go, the fixed distance will be the same. So for now, it's actually really handy to use this function. Now, this line is also a fixed distance. So if you want to change it, you might have to um, create a line which is independent from the constant factor. So let's put it in here. So now I have a new line wherever I want to put this. Okay, so let's put it here. Let's be, so that's gonna be, well, a little bit too tight, but that's okay in this case. I can be that accurate like that. So this is in there. So I'm gonna not even gonna use this line anymore. And now we talk about the top line. The top line, we can do the same exact thing. So we are, first of all, we're going to create a line from these lines. So now this is called union line, and I can put that union line on the other side. There we go. And I can even hide these construction lines. As you can see, the union line just goes wherever I want this to go. In this case, and I can change the shape of this fillet wherever I want to change it. Pretty neat. If I want this to be graded, again, this is all I need to do. And I can even play with the orientation with the other line, because this is probably a little bit better choice than the previous one. There we go. And it's still gonna work business as usual. So wherever I want to measure this distance. Now let's talk about this curve up in here, because this is also something what riders want to change whatever they like, or I want to change whatever I like. So here we go. Gonna put this in here. And the first thing I'm going to do is just create a line from here to, let's say, there. And I have full control over this curve just using these control points. There we go. And now I'm going to put these next curves to this line, going for the intersection. And super important, stitch it to the intersection. And I'm going to do the same thing in the other side. And actually, let's put it in here. Now, I can control this curve. There we go. And instead of this, I have a fully parametric top line. So I can do this. Wherever I want to put this, okay. If I want to change the shape, of course I can. I can change the shape this way. And why this is pretty brilliant now? Well, because everything is parametric. So I move this line, everything will change. So dear customer wants to have certain measurements. I put it right there right away. If this needs to change, I can put it wherever. I'm going to put this into independent line as well. And now, as you can see, it's grading beautifully. And let's talk about that grading for just one quick second. So I'm going to create a piece from this using the union line, using these lines. There we go. And I'm going to use this line on this side and the same. Of course, it's missing an allowance, but let's not worry about that for now. Okay, so here we go. Here's my parametric design. I put these lines by the measurements I have in there. And here's the problem. So this is gonna get a rough ride from now on. These differences here are determined by the width measurement, because this is the width measurement, length and width. So the problem is, if I measure the distance between these guys, so let's put it this here, is going to be 8.5 millimeters. That's a lot. So this is might not entirely realistic that I grade a boot like that. So how can I prevent this boot to go to the high sky like that? And that is the secondary grading axis. I'm gonna put this right here. And just to show you what this is gonna do, I'm gonna hold the width measurement. Again, the width measurement is the one which determines the height in this case. So as you can see, this direction. So I'm going to hold the width measurement, and I'm going to associate this line with that rule in there. So what did this do? Uh, well, let's see. So as you can see now, every single uh, boot is the same exact height. And is it realistic? Well, it's realistic in the Western boot making world, because 17 boot top is a 17 no matter what is the size. Here, on the other hand, is probably not. But look at this beautiful thing in here. The length of the height of this shaft is held in its place. Okay, so it's not gonna go anywhere. The width, on the other hand, is grading as it's supposed to be. Okay, and that's actually pretty cool. Now, what if I want to have a little change, but not this much? So let's say I want to add a couple of millimeters width. So let's put there 2 millimeters, okay? So 2 millimeters, and I can actually put it here. So it's regrading from uh, the bottom of that. And then let's see what happened. Well, it's changing. Not 2 millimeters though. Why not? Oh my God, what happened? So let's measure it. This is almost 5. That's not what I was hoping for. So this is always a proportion, not an increment. A grading axis is an increment lengthwise, but that's also proportional to a certain size. This one here is a proportion. So if I want to make it proportional, I have to measure this distance right there. And this is 355. And if I want to have it accurate, I have to put this measurement here. It's nothing to do with the actual grading. It has to do something with the proportion. So this proportional to 2 millimeters, and that's going to dictate the grading. So let's see what's happened now. As you can see, well, hopefully it's 2 millimeters. It could be a little bit off in certain places, but as you can see, it's actually pretty darn close to 2 millimeters. So 700ths of a millimeter difference, that's not too bad. And this could be just my placement at the beginning. So this is how you can control the height grading. Or if you want, actually there's another brilliant way to do this. You can go with groups. So let's say you say that you want to have 37, and that's going to control these, 41, and then you're going to go 44. So now you have 3 groups. These base numbers are still calculated with this proportion right there, but the rest of it all the calculations are gonna be ignored because we did a group rule for the top line, not the whole thing, just top line. So now we have three heights in this boot grading, only those. And this actually makes a ton of sense, not because of being comfortable with the cutting, because maybe you have a um, extra piece, maybe you have a tooling, maybe you have some kind of embroidery or stamping or whatever not, and you don't want to create 11 different forms for that thing or tooling. You want to do one tooling. So in this case, you can do as many toolings as you want. You can keep that shape the way that you want. So in this scenario, this top is only three different shapes. Well, there's a little bit of a grading sideways, but let's ignore that couple of millimeters for now. If you want to go for three different heights, this is where you how you do it, and you did it. Thank you for watching this, and next time we can talk about other juicy grading issues.